So moving on to question 5, a rigid 5-liter vessel. Now for question 5, I would like you to take note that in your tutorial question it's written 6-liter over here, and over here it was written 2 liters, okay, if I'm not mistaken. But please, if it's written 6 and 2 over here, please change it to 5 and 1. That is the correct value. Okay, but no harm done because the method will still be the same. Okay, now a rigid 5-liter vessel contains 4 liters of liquid water, which is in equilibrium with 1 liter of water vapor at 25 degrees Celsius. Heat is transferred to the water by means of an immersed electrical coil. The volume of the coil is negligible. Use the steam tables to calculate the final temperature and pressure of the system and the mass of water vaporized if 3915 kJ is added to the water and no heat is transferred from the water to its surroundings. So we need to calculate the final temperature and pressure. So this one we have to do a bit of iteration. Oh my, sorry for the blur image. So you have 1 liter of vapor coming in and 4 liter of liquid coming in at 25 degrees Celsius. And then it will leave as vapor phase and as liquid phase. So ME is your evaporated liquid, right? The kg of H2O vaporized, ME. Now, the initial condition, we will take table B.5 and look for the internal energy of L1 over here and the specific volume of L1 at 25 degrees Celsius. And we'll also take the pressure down also. So at 25 degrees Celsius, saturated. So for the liquid phase, we look at the column where it writes water. So over here we look at the column where it writes vapor. Sorry, this one is vapor, this one is water. And look for the values here. Okay, so MV1 is equal to 1 liter divided by its specific volume. Okay, so this is MV1. And ML1, 4 liters divided by its specific volume, and that gives you 3.988 kg. So for your energy balance, we have the change in the internal energy equals to Q, and that gives us MV1 plus the evaporated mass of H2O multiplied by the internal energy as a function of the final temperature plus this minus 3.988, okay, minus the evaporated water, okay, multiplied by the internal energy of here, which I found as a function of the final temperature minus this, okay. So this is MV1 multiplied by this minus this multiplied by, okay, where is this? Here. Okay, and that gives us 2915 kilojoule. Okay, so bringing forward, simplify your equation and we get ME to be this equation. Now this is your equation 1. Now we use the volume here, okay, so volume, the specific volume, so multiply M with the specific volume, okay, so M here is this mv1 plus the evaporated mass, okay, in kg. Okay, do the same thing, 3.988 minus the evaporated, multiplied by the specific volume, the liquid phase, as a function of TF, and that is 5 liter. So rearrange your equation and we will get this equation 2. So take equation 1 minus equation 2, and this gives us a function of TF, and we have this equation. So in this case we will need to do interpolation. Okay, so we'll start with, say, 201.4 degrees Celsius. So get their U, V, UL, VV, and VL. Substitute the values into this equation and solve for your F. Now in this case, how do we know when we get the correct answer for the final temperature? Is that when you substitute your U, V, UL, VV, and VL into this equation, we will get the value to be very, 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 very close to 0, or it could be 0. And in this case, at 196.4 degrees Celsius, we get F to be equal to negative 4.03 times 10 to the power of negative 4. So this is a value very close to 0. Therefore, our final temperature is approximately 196.4 degrees Celsius, which is at 14.4 bars. Okay, so using equation 1 or equation 2, we can solve that the evaporated mass of H2O is 2.6 gram. Okay, now in exam you will ask, how am I supposed to know that that this is enough? Now don't worry, you will be mostly given mass. I mean, from my experience with how I know JJ is that she will give this kind of marks based on the steps. So even if the value is not really close to 0, you may stop here. Okay, you can consider this as 0 because this is negative 10 to the power of negative, which is quite close to 0 as well. Okay, but you may still get marks. It may not be close, but the steps are that's important. Alright,